in two variables. Slope-intercept form, we know it, we love it, it's our favorite, right? At least of all the linear equations. Probably the easiest, most common, okay? We looked at some of these yesterday in the past. When you're given the slope and you're given the intercept, you can plug in the y value for b, you can plug in the slope for m, you've got your equation slope-intercept form. Slope-intercept form is also one of the easiest forms for graphing a linear equation because it gives us a starting point of the y-intercept and it gives us the rate of change with the slope. So we can use that to get subsequent points. So if I'm given an equation that's not in slope-intercept form and I want to graph it using slope and the y-intercept, we need to rewrite it in slope-intercept form. So walk me through. X plus 2y equals negative 4. Let's write it in slope-intercept. Subtract x and divide by 2. Okay? So subtract x from both sides. 2y equals negative x minus 4. Divide by 2. Y gives me, what's my coefficient of x going to be? After I divide by 2? Negative 1/2. There we go. Minus 2. Okay? So what's my slope?
Wait, why is it negative? Oh, no, the 1 right there.
1/2.
Wait.
I subtracted the x, which makes it negative, then divided by 2. If I had a coefficient of 1, now it's negative 1/2. Okay? My slope is negative 1/2, and my y-intercept is ordered pair 0, negative 2. 0, negative 2. All right? So, I'm going to start where? 0, negative 2. Right there on my y-axis. Boom, boom, boom. And a slope of negative 1/2 means I do what to get to my next point?
Drop 1 and go right 2.
Boom. Down 1, right 2. Okay? What if I wanted to go the other direction? What would I do? Up 1, left 2. Okay? Negative slope goes down and to the right. So please make sure that you are matching up.
So,
yeah.
How do you get 0 minus 2?
The b value is the y value of the y-intercept. And all y-intercepts have x value of 0. So when we have a negative slope, pay attention and make sure your slope is actually going the right way. It's just a quick check to make sure you went the proper direction. Okay? Negative slope goes down and to the right, so make sure your slope matches up. Positive slope would go up and to the right. All right? The easiest way to graph is slope-intercept form. Now, yesterday, some of you noticed this equation on the assignment, but may or may not have remembered it. Point-slope form. Okay? Point-slope form actually derives from the formula for slope. Okay? The formula for slope is y2 minus y1 over x2 minus x1. Okay? Notice how we have, let's get my highlighter, we've got this, and we've got this, we've got this, and we've got this, and then we've got our slope. Okay? By multiplying our slope formula by that denominator, x2 minus x1, it cancels that out of the denominator and moves it over with the slope, and then we get point-slope form. Okay? So point-slope form and slope formula are basically the same equation, just written slightly different. Okay? Point-slope form, we don't really use it for graphing. It's more of a tool for helping us write linear equations when we don't have when we don't have the y-intercept. Okay? So either we're given the slope and some point on that line that's not the y-intercept, or we're given 2 points on that line, neither of which are the y-intercept. We use point-slope form to find that equation. Now with point-slope form, usually from there we write it in one of two forms. We'll either write it in slope-intercept form or we're going to write it in standard form. Rarely do we leave it in point-slope form. This is just kind of a tool that gets us to either slope-intercept or to standard. Okay, so those are the two ways that we're going to be writing. When you do your assignment on 3.3, you need to pay really close attention to the directions. There's a little blue text under the boxes, and it will say write your equation in slope-intercept form, or write your equation in standard form. So I'm going to show you how to do both, but you need to be aware of what form the question wants the answer in. Okay? Some of them are multiple choice, you just pick the one that's going to fit. Okay? But you need to be able to take it from point slope form into either y-intercept or into standard form. Note and remember the difference, y-intercept, y equals mx plus b, y is by itself. Okay, so we're isolating y. Standard form, x and y are on the same side of the equation. Okay, that's kind of the big difference between slope-intercept and standard. Slope is y is by itself. Standard gives us x and y on the same side. There's also another caveat with standard, and I'll talk about that in just a minute. All right, so we want to find the equation of this line with a slope of 2/3, and it's passing through the point 3, -4. It's not the y-intercept, so I can't use slope-intercept form. I have to use point-slope form. All right. Luckily, if you remember, hey, I have a point and I have the slope. Point-slope form. Like, we're not clever. We name things for what they are. All right. In point-slope form, your y and your x are never going to change. They represent the line. Okay. They represent the x and the y values of the line. The only thing we're plugging in is y1, x1, and the slope. That's it. And then we simplify from there. Okay? So looking at our equation, I'm going to leave y alone. What's y1? -4. What's my slope? And what's x1? 3. Okay? So those are the only values that I'm plugging in. Leave x in there and leave y in there. Okay? Because you need those for your line. Okay? Now, clean this up a little bit. When I got a double negative, that becomes positive. So this is point slope form. Okay, one of our 3 forms of a linear equation. Rarely do we leave it in point slope form. Okay, sometimes we do. Okay, because it's not really useful for a whole lot else other than finding the point of the slope. I mean, we could graph with it, but it's not the most useful. So we rarely leave it in point slope form. Y-intercept is the next form that we're going to go to because it's the easiest one to get to. Okay, so I need to do 2 things in order to turn that into slope-intercept form. What 2 things do I need to do? Okay, what 2 things do I need to do to get that to happen? Distribute. Okay, distribute. So I get y plus 4 equals 2/3 x, what? -2. All right, and then what's the last thing I need to do? Y equals 2/3 x minus 6. So there's slope-intercept. Slope-intercept. Okay, there's slope-intercept. Last thing we're going to do is we're going to write it in standard form. What did I say was important about standard form? What's the key difference between slope-intercept and standard form? X is on the same side as y. Okay, so how do I get that x on the same side as y? Subtract 2/3 x. So if I want to take y equals 2/3 x minus 6, if I subtract 2/3 x from both sides, minus 2/3 x, minus 2/3 x, that'll move it from the right side to the left. Negative 2/3 x plus y equals -6. Now there's one more caveat with standard form. With standard form, we don't like fractions. Okay? We want all a, b, and c, our coefficients and our constant, to be integer values. How do we get rid of fractions? Multiply by what? Not by the reciprocal. What can I multiply everything by that's going to get rid of that fraction? Common denominator. Which in this case is 3. Multiply everything by your least common denominator. In this case, it's a 3. Whatever your LCD is, you're going to multiply. Distribute, 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 all the way across. 3 times negative 2/3 gives me negative 2x plus 3y equals negative 18. And that is standard Okay? So taking point slope form goes into slope intercept, and then we can take slope intercept and loop it into standard. Okay, so those are the three different notations for our linear equations. Certain questions will ask for either one.
So what did this question ask?
It didn't, so I did all of them. It will specify. It'll say, right, yes, ma'am. Now, if you have a question too, or you're stretching. Find the equation on the line passing through those 2 points that are given. Write the equation in standard form. So this one specifies, so we need to go to standard form. All right, so that's what we need to make sure. We have it in ax plus by equals c notation. Okay, now point slope form is kind of our go-to, but what am I missing from here in order to use point slope form? Slope. So what can I use to find the slope? Slope formula. Okay, so we'll start with slope formula. y2 minus y1 equals x2 minus x1. So now I've got my slope. Now I can go ahead and plug in the slope, point slope form. Y minus y1 equals mx minus x1. Okay? Now, we've got all these different forms of linear equations. So, let me put it this way. I'm not going to make you memorize each form. I will give you like a formula list, but I'm not going to label them. Okay? So I'll list out all the forms, but I'm not going to tell you what each one is. So as long as you can recognize what a slope formula is, what the point slope form is, what the standard form is, okay, I'll provide that. I'm just not going to label what anything is. Okay, so you need to make sure that you can each of those forms. All right? So what am I going to do with y? Leave it. What am I going to do with y1? Plug in a y value. Either one. Doesn't matter which one. Sure, let's do 6. Okay? What about m? Negative 2/3. Okay? What about x? Leave it. Now, because I chose 6, what do I have to pick for x1? Negative 2. So minus negative 2 becomes plus 2. Minus negative 2 becomes plus 2. Alright? Now, in order to get it in the standard form, usually we're going to end up writing it in slope intercept and then going from there. So what am I going to do next? Distribute. Always get rid of that parentheses first. Let's go ahead and distribute. Y minus 6 equals negative 2/3 x. Okay? Not subtract 6. Add 6. So y equals negative 2/3 x. Negative 4/3 plus 6. Yep. Okay? So now I'm in slope intercept. I'm not done yet. Need to get it in standard. Times by 3, we can do that part first. That's fine. Get rid of the fractions. That's important. Okay? So we end up with 3y equals negative 2x plus 14. I'm going, well, it's negative, so what's the opposite of a negative 2? Add 2x, okay? So add 2x, so 2x plus 3y equals 14. Okay, so we got standard form. Alright, so this just kind of reviews all the different forms, important information that we can get from them, where they're most useful. Slope intercept form gives us slope and the y value of the y-intercept. It's usually the quickest to graph the equation. Point slope form, we use it for finding an equation, given slope and given a point. Okay. Standard form, it's used to quickly graph, but more specifically by finding x and y intercepts. That's where our standard form comes into play. Again, a, b, and c have to be integers. Okay, they have to be integers. Then we've got a horizontal line and a vertical line with their respective slopes, as well as the intercepts that are given from those equations. All right, word problems, everybody's favorite. Okay. Oh, collective groan. I'm gonna make it really easy. Really easy. You need to know two things. You need to know two things. That's it. Two things, and it all comes from slope-intercept form of an equation. Okay. Slope and intercept. Okay. You need to know two things. The first thing you need to know is rate of change. The second thing you need to know is constant. Only two things in a linear equation. Slope represents rate of change. Rate of change. B, our y-intercept, is a constant. Okay, that's what a constant is. Just a number by itself, no variable. It's a constant. So when we look at a linear equation, we've got slope, which represents rate of change. And we've got our y-intercept, which is a constant value. You ask yourself when you read the question, what is a rate of change and what is constant? And that's where you fill in those numbers. With what? Why is it rate of change?
Because it's per minute.
It's per minute. Suppose there is a flat rate of 20 cents. That's never changing. That's constant. It is a flat rate of 20 cents. That is constant. Okay, plus a charge of 10 cents per minute. The longer you talk, the more expensive it is. So that is our rate of change. That is the rate of change.
That's like, what, $1 every 5 minutes?
It's a dollar every 10 minutes, but yeah.
Yeah, like that's wild.
Oh,
Wait, that's good, that's good, that's good.
I swear. Fun fact. Actually, some of us were talking about yesterday when cell phones first came out. It was like 25 cents a text message and
Wait,
You know, like 120 minutes.
yeah, you would pay for a certain number of minutes, and then it was like 10 cents a minute extra, or 20 or 30, depending on your cell carrier. Mr. Wexler was seeing a girl, I guess long distance, and he racked up like a $400 cell phone bill talking to this girl outside of their minutes. It was, and you know what? I've heard that story plenty of times. I actually had this girl, I had 150 text messages a month. That was my plan. Okay? I got 150 text messages a month. I was texting this girl, and towards the end of the month, and I ran out of messages. Okay? And it was 25 cents a message after that. And so I'd be like, hey, I'm out of text. I'll get more on Friday. I'll see you at school tomorrow. She kept texting me. Girl, you're cute, but you're not that cute. You're costing me money. I will see you tomorrow.
So if they text you, you get charged?
If I opened it. If I didn't open it, I'd get charged.
Oh.
So I'm good.
But if she texted it and I opened it, then I would get charged 25 cents.
This one, I would just call you.
Be
That's
like,
like every time somebody else texts you, that's
if I opened the text message, yeah, like you get a little whoop, and if you opened it, it cost me 25 cents.
so if you send a message, it's also 25 cents?
Yes,
That's stupid.
that's just how it
You
was.
can't control if somebody else sends you a text.
But
That's
it got expensive quick. When they came out with unlimited calling, then they did like your circle, and so you pick like friends and family, and you could call them for free, but anyone else would use up your minutes, and then you got free nights and weekends. Ooh, that was a big deal. After 8, it was free. Oh man, that was a big deal. So, oh man, you have it easy. You don't even know. Okay. All right. So constant rate of change, we plug it in. So my rate of change is 10 cents. So y equals 0.1x plus my constant of 0.2, and boom, there's my equation. And if it asks for anything specific, we could say, well, how much would it cost if we were on the phone for 20 minutes? Plug it in for x. And, okay? 20. You could use the equation to answer any other questions that stem from that. All right? You can change your friends and family once in a while. Move people in and out.
It's like, imagine if you like not friends.
Just be like, nope, you're out.
So wait, it'll only at the end of the month?
At the end of the month, you can change.
So if you had like a girlfriend or something in your circle and you broke up, you would have to
You gotta wait till the end of the month to get somebody new in there. Yeah.
Oh, no.
Keep working.
Alright. Percentage of the U.S. population 25 years and older with at least high school diploma, yada, 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 yada. Focus up. This is the last one. Okay. We want to write an equation that models based off this graph and this lovely accompanying chart. Okay. Find an equation that models the data using x equals 0 represents the year 1940. Makes it really easy because we can see, oh, here's x equals 0 is going to represent 1940, and we've got these x and y values to match. Okay, so for the year 1940, we had 24.5%. Oh, look, we have this point right here. Okay, so that chart matches up with the graph. The graph helps us identify the x values. The chart helps us identify more precisely the y values. Okay, so I want to write an equation. Again, slope-intercept form is kind of our default because those are the easiest things to find, especially given a chart. What's my y-intercept going to be? Specifically the y-intercept, so it's not any point. Yeah, there's my y-intercept, which corresponds with that first row on my chart. So my y-intercept is going to be 0, 24.5. So my b value is just 24.5. Now I need to find my slope. What do I have to use in order to find my slope? Slope formula. Okay?
Can't you do rise over run?
Well, it's not a perfectly straight line. Also, there's a lot of decimals and we would be guessing. So we need to use, we're looking for basically a line of best fit. So we need to use our data points from the chart and our slope formula. So let me change color on this one. Let's do red. So m y2 minus y1 over x2 minus x1. Now, it's usually best to pick the first and last point. That's going to give you, all right? So what 2 points are we going to use? So we'll use the year 1940. Now remember, these aren't our x values. These are our x values. So what's my ordered pair for my first point? So I've got 0, let's go ahead and write it down here. 0, 2, 4.5. And what's my ordered pair for that last one? Close. 60, 80.4. Okay? So there's our x and y's. Now we can plug those into our slope formula. All right? So 80.4 minus 24.5 over 60 minus 0. 80.4 minus 24.5. That's about right. 56.5? Or 56.9? 55.9? 55.9. There we go. That looks better. Okay, over 60.
Whoa.
That's 4.5. Now, do the division. Give me a decimal. 0.931. All right. Slope 0.931. x plus 24.5. As a general rule with when writing your equations, don't mix fractions and decimals. Okay, so if you have a decimal for your y-intercept or for your slope, you want to make sure that they match. It's just in bad form to write a fraction for your slope and a decimal for your y-intercept. So if you have a fraction for your slope, make sure you have a fraction for your y-intercept, or vice versa. As long as you're consistent, that's fine. But there's our equation that models our scenario, and then we could use this line to estimate for anything in the future. Okay, so if I wanted to estimate what would be the percentage in 2010, I could plug in 70 for my x value and then solve, and that would give me an estimate based on the trend of the data. All right? I could also do for years in between. I could estimate, well, what about in 1965 or 1999? I could plug in corresponding values for x. It'll let me estimate it based on that trend, even though I don't have those specific values for those years. All right? Questions, comments, concerns, queries, or